Okay, so graphing systems of equations that are inequalities. You're going to graph, we're just doing linear still, so these are just lines. And you're going to graph them just like you would graph any other line. So it's easiest to put it in y equals mx plus b format. Okay? And then after you graph the line, you're going to see, okay, do I shade under the line or above the line? And I taught Algebra 1 like a while back. And so I know that sometimes that can get a little tricky. And so I'm going to show you that testing a point is actually a really good idea during these, okay? So let's look at one real quick. Oof. Okay. So this first one, we have x plus y is less than or equal to 6. So we want to rearrange that so that it's y by itself. So in order to do that, all I have to do is subtract x. Agreed? If I just want y by itself, I'll have to do on this top one, I'll have to do is subtract x. So I'm going to get y is less than or equal to negative x plus 6. Okay, and then we can put that in the calculator. Okay, from there, you want to test a point. So I like to use 0, 0 when I can. So if I put 0 in for x and y, and I should have wrote over here, y is less than or equal to negative x plus 6. Well, you would get 0 is less than or equal to 6. Is that true? Is 0 less than or equal to 6? Yes. So because the statement came out true, that means 0, 0 was included in the shaded area. So you would know that you shade down here, right? If it was false, like if it was the other way around, let's say it said 6 is less than 0, you would know that 0, 0 wasn't an answer and you'd have to shade up here, okay? So the testing point helps a lot. All right, then you're gonna wanna graph the second line, right? And so the second line is that 2x minus y is greater than 4. I want you to subtract the 2x, right here, subtract the 2x. And then you're left with negative y. Do we ever want a negative y? No. So I'm going to divide everything by negative 1. Who remembers what happens if I divide by a negative with inequalities? You flip the sign. Good. Okay? You flip the sign. So you'll end up with y is less than, it will be a positive 2x minus 4. If I graph that, I get this. And if I tested 0, 0, I would see that it doesn't work. And so that's why I shaded to the right. Okay? Because shading always seems to hurt. So what happens, though, if I take the two graphs and I put them on top of each other? Right? So if I would have graphed them on the same graph rather than separate, I would get this. Right? And so where the brown region is, those are where the two shaded areas were on top of each other. It's where the green and the red went on top of each other, right? And so it became brown on this screen. That brown area are all the solutions that work. Those are all the answers. Okay? And so like on a test, you're going to have to shade, and where there's double shading, that's where the answers are. You could also on the test, maybe I would say something like, is 0.00 one of your solutions? So is 0, 0 a solution? Is it in the brown area? No, it's only in the green. So it's a solution for the green, but it wasn't a solution for the red. So that means it's not a solution because it needs to be in the shared area. Okay? But what about, let's see, 2, negative 2? 2, negative 2. Is that in the brown? Yes. So 2, -2 would be a solution. One of many, right? There's lots of solutions. So what were the steps we did? We graphed the first inequality, and you can use one colored pencil, and do it lightly, right? And then you can graph the second one lightly, and then shade over darkly where they have in common. And those are your answers. Those are your solutions, where they share the two colors, okay? All right, the next slide, just because you guys have access to this on your Google Classroom. This just reminds you, before you do it, make sure you put it in slope-intercept form. And then you could just graph the y-intercept and the slope, or you can put it in the calculator and do it, okay? A reminder, though, is a solid line is used when there's an equal sign under, but a dashed line or a dotted line is used when there's no equal sign underneath, okay? And so that's kind of like that open close that we had been doing last time when we did inequalities, right? A closed circle versus an open circle. Same idea here, but instead of a circle, it's a line. And so the line is either solid, right? That'd be included, or it's dotted because it's excluded. That means the answers aren't on the line if it's dotted, okay? All right, so let's try another example. So we're going to graph the linear system of inequalities. So we have y is greater than or equal to 2x minus 4, and y is less than -3x plus 2. They're already in slope-intercept, so we can just grab the y-intercept, which here is -4, and then we can go up 2 over 1. That's the slope. I can draw a solid line for this because it's equal to. Now the question is, where do I shade? Okay, do I shade up here or down here? Well, it's y is greater than. So what's your guess? So your guess is up here? Is that what you said? Up? Okay. Well, let's test this to be sure, because if somebody gets confused, right, let's test it. So I like 0, 0. So if I plug in 0, 0, I'm going to get 0 is greater than or equal to -4. Is that correct? Is 0 greater than -4? Yes.
Yes.
0 is greater than -4. So yes, you were right. I shade here. -4. Okay. Now we got to do the second equation. So we're going to graph y is less than -3x plus 2. The y-intercept is 2. So I'm going to put a point at 2. And then I can go down 3 over 1 for the second point, because that's the slope. You can also do it on a calculator, but this is easy because you already get, here's the y-intercept, and then down 3 over 1. And it's going to be a dotted line or a dashed line because it does not have an equal sign. Now, the question is, do we shade to the right, up here, or down here? What do you guys think? So it's y is less than that line. So you think it's going to be down here? So let's test it, just in case. I'm actually going to pick a different point. I'm going to pick -2, -2. So if you plug in -2 for y and -2 for x, you get -2 is less than 8. So -2, -2. Is -2 less than 8? Yes, so this would be the shaded area. So you're correct. Okay, now what happens when they overlap? Let's go back.
They're equal to each other?
Yeah, so where do they overlap? Well, this one was underneath, and this one was this way. So they overlap right here. Okay. There we go. It will be. Okay, so this is the answer. All these are the answer in that shaded area. All right, I want you to try one. So try this on your piece of paper. Go ahead and graph these two lines and find the shaded area. On here, this is an example. This is why I don't give you guys work yet. We haven't started the work yet. Okay, so you should be about done. Not too long.
Paper that you told us to pass around?
Yeah, I have more. Give me a sec.
I didn't get it out. I was wondering if you could. It still said I had that paper.
Okay, so we're going to graph it on here. So let's try it. We have y is greater than, and do we have a sign in here for greater than? It's okay if we don't. So we're just going to do y equals negative x. Why is it being so slow? Sorry. Negative x plus 4. Okay, so this should have been your first line. And instead of equals, though, we have y is greater than. So if y is greater than this line, which way do you think I'm graphing or shading? Up, good, okay, up here. The way to test it is we could put 0, 0 in. Is 0 greater than 4? No. So we know that 0, 0 is not included. So we shade up here, okay? And then the second equation is y is greater than x minus 1. I'm sorry, x minus 2. So that's this gray one. But y is greater than this line. So which way do you think we'd go? So the question is, if I plug in 0, 0, is 0 greater than negative 2? Yes. So I shade this way. So where do the two interact? Remember, we shaded this way, and this one we shaded up here. So it should be this like little triangle part up here where they share the shading, okay? Also, I can't do it on here, but should they have been dotted lines or solid lines? Did they have a little equal sign underneath them? They didn't. So they should be dotted lines, okay? Okay, I'm going to stop with those examples, but I want to go to word problems real quick, okay? Because these can be a little tricky. And so you'll see here, we've got linear inequalities, okay? And then I'm going to be giving you something else called linear programming. I'm going to steal it from over here real quick. I didn't put it up yet because I wanted you guys to focus, but I'm going to put it up. So linear programming, I'm going to give you the notes for this, okay? Linear programming is a method where we still have linear equations or inequalities or both, okay? And we got to determine the optimal solution of certain situations. Meaning inequalities are great and we're graphing them when we're shading them. But like, what if we're thinking about, I don't know, selling tickets to a concert or something? Would I ever have negative ticket sales? No. So even if I was shading somewhere, I got to be careful because it doesn't make sense, right? So the equation will include negatives. Like if I were to actually write the equation and graph it, but then you're going to have to either erase it or just ignore the negatives because that wouldn't make sense. And so we're going to take some word problems in different situations and we're going to find out what constraints they have. Okay? So we're going to use the constraints to write systems of inequalities still and find out what the limitations are to the problem. Okay? And so once we do that, we're going to be drawing a bunch of different lines. And the best way to do this is something called test the vertices. So the vertices are going to be the ends of where like the lines meet, right? And those are going to be the crucial points because it's going to be like the edge of the solutions are either going to be the maximum or the minimums or things that you need. And so this testing the vertices is really going to help you see where the situation has a better answer, okay? So let's try one. So the first one says that we have a small plane, and it's the smallest plane for this coast-to-coast airlines, okay? And you might want to write this down as we're doing it, okay? They can only hold 50 passengers on the plane. So that's the maximum passengers on the plane. So that's very important. So nowhere am I going to have something over 50 on my graph because I can't sell 51 seats. It just doesn't exist, right? So right there, that's already a constraint. So I like to write down my constraints. So one of my constraints is going to be I only have 50 seats, right? Now, in order to actually charter the flight, meaning they have like enough money to have the flight go, they have to sell at least 8 first-class tickets. So the minimum first-class ticket is 8. That's another constraint, okay? Because if they only sell 5 first-class tickets, they don't have enough money for fuel and whatnot to actually run the plane. So first-class tickets, it has to be 8 or more. Okay. So then let me keep reading. So then the airline says they need to sell at least 20 tourist tickets. So that's like, you know, the regular seats. So we need 20 of those or more. So we can't have 19, we can't have 18, we have to have 20 or more. So it's another constraint. Then it talks about money. And this is the part that we will look at later after we graph the constraints, okay? So the money part says they make $40 profit for every first class and $30 for every tourist ticket. If the company wants to maximize their profits on a single flight, how many of each ticket should they sell? You might already know the answer, like just thinking about it. Because if you get those constraints in, you can start writing down and seeing where they are. But let's graph them and see what we have. So I'm going to use X for first class tickets and Y for tourist tickets, just to make it easier. Okay, you could have used F and T or whatever, okay? So I know that X plus Y, first class plus tourist, has to be less than or equal to 50 seats. The combination of the two can't be more than 50. And so I started off with X plus Y is less than or equal to 50. Okay? I'm going to change it so that I can graph it a little easier and get a line. So I'm going to do Y is less than or equal to negative X plus 50. So my first constraint got me this equation. My second constraint said X must be greater than or equal to 8. Okay, so first class tickets have to be 8 or bigger. Okay, when we have an X being a line, we get a vertical line, right? And so my vertical line, we're going to say X has to be greater than or equal to 8. Y must be greater than or equal to 20. That's a horizontal line. So my Y values have to be 20 or larger, right? But be careful because as we create these vertices and as they overlap, we're saying that Y has to be greater than 20, but it also has to be less than what? How many passengers can I have? 50. But I also have to have a minimum of 8 first class. So what's 50 minus 8? Okay, so that's actually your minimum tourist. You see that? Like logically? So if I graph it, it's going to give me this. And it gives me this little triangle situation. Okay, and so we right here said, okay, tourists have to be 20 or more, but you also told me it has to be 42 or under because you have to have 8 passengers. And look, we can see it right there on the graph. Let me zoom in a little for you. It ended up being one of my vertices. But logically, you were able to tell me that 42 tourists and 8 was 50, right? And so if 8 is the minimum of the first class, 42 would have been the maximum. Okay? Down here, 20 is the minimum for tourists, and 8 is the minimum for first class. That's only 28 passengers. Is that under 50 though? Yeah, so the minimum to fly would be these 28 passengers. That's another vertice. Now, think about this one. This is the other vertice where they intersect. 30 first class and 20 tourists. Does it meet the requirements? 20 tourists, that was the least amount, remember? 8 or more first class. Well, that's definitely more than 8, it's 30. 50 passengers total. Yes. But what do you think ticket prices? Which one of these 3 do you think is going to be better? So remember, the first class tickets were $40 and the tourists were $30. So out of these 3 situations, which one's more money? And that's what we're trying to figure out. So I'm going to test those vertices. So 8 first class times $40, 20 tourists times $30 gives me 920. That was only 28 passengers. So that makes sense that that's only $920. That's the minimum to fly the flight because they need gas and all this, and right? All right, now here's the minimum first class and the maximum tourist. 40 first class, $40 times the first class, $30 times the tourist, I get $1,580. Okay, that's better. But look what happens when I have lots of first class and the minimum tourists. $40 times 30 first class, because those tickets are more expensive, plus $30 times the 20 tourists. So my maximum profit is $1,800. Okay, and I met all the requirements. And sometimes you'll start thinking about this and you might be able to come up with the answer without graphing it. The graph helps you see it to find those vertices, the edge points. But you might have went, well, if I sell more first class tickets, I'm going to make more money, right? But you still had to sell 20 tourists. That was the minimum, okay? And you only had 50 seats total. Does that make sense? Okay. Let's try one more. So the answer here was 30 first class and 20 tourists. That gives you the most money. Okay. Okay, let's try one more. We have a hairstylist in this one. Okay, so she's making appointments. If someone's coming in just for a haircut, it takes 30 minutes. Okay, 30 minutes. If someone's coming in for a cut and a color, it takes 2 hours. She has 10 hours available for the day. So she works 10 hours. Okay. She likes to see 8 customers, no more than 8. So 8 or less. Okay. And then we've got the money. So she goes for one haircut, it's $40. For someone that's doing a cut and a color, it's $100. How can she maximize her money with following her restrictions? So her restrictions are 10 hours of work, 8 or less clients. Okay. Well, which one's worth more money? The cut and the color, right? But it takes 2 hours. How many of those could she do if she only did those? So she has 10 hours of work and a cut and color takes 2 hours. So how many customers could she have if she only did cut and color?
5.
Good, 5. So you're already seeing the restrictions. She can only have 5 customers that way. But she would make 100 times 5. She'd make how much money? 500, right? So the question is that the most she can make? Like, is that the best option? Well, let's see. Yeah. So let's say cuts are X and cuts and colors are Y. And to do it in hours, X is a half hour. So that's why it's a half, okay? It's only 30 minutes. So we did a half X plus 2Y is less than or equal to 10 hours. So we get this line here. Then we have that she can only have 8 customers, 8 or less. So X plus Y has to be less than or equal to 8. And then this is one that we didn't really talk about or think about, but you can't have negative numbers. So just know that you can't have negative customers, okay? So we just put that here to make you think X and Y can't be negative. And really, they can't be less than 0 at all. They can be a half a person. You can't have half a person, right? Okay? So that's why we put that there, just in case. So if I graph these, right? This is that line right here for the hours. And then I start graphing these other ones here. This is Y is less than or equal to negative X plus 8. Okay? And I get these. But my vertices are going to be 0, 5, and that's what Haley told me, right? Because 5 is the maximum. If I had 0 cuts, 5 would be the maximum. What if I had no cut and color, but all cuts? How many could I have? Well, she can only have 8 customers, so 8 would actually be the maximum. But time-wise, how much time would she be doing? If she had 8 customers that were only cutting their hair, how many hours would she be working? Nope. How long did a cut take? Half an hour. If she can only have 8 customers, right? It's only 4 hours. So she's not maximizing her hours there. So that's a horrible idea. 8 total customers with just a cut, she's not going to make very good money there. My other vertice is where they intersected. And that happened to be 4, 4 here. So we're going to test that out money-wise. So we had already said if she only does cuts and colors, she would make $500. If she only did cuts, she would only make $320. But if she does both and she splits up her time, the maximum time and the maximum money would be $560. Okay? That's splitting it up and seeing where can I do both where I'm only having 8 customers though and 10 hours of work. Okay? So there's more of them and I'm going to post these on Google Classroom for you guys. Okay? And then I'm going to post, sorry, I'm going to stop recording for you guys real quick. So I'm going to